Hello and welcome to our Quiz 1 review video. This will hopefully help you review a little bit for our quiz, our first quiz of our conic sections unit. So as a reminder, these notes are going to be over all 4 of our conic sections that we've been learning. So just be ready for that. If we're looking at this first problem, the filament of a light bulb is a thin wire that glows when electricity passes through it. The filament of a car headlight is at the focus of a parabola or of a parabolic reflector, which sends light out in a straight beam. Given that the filament is 1.5 inches from the vertex, find an equation for the cross-section of the reflector. So what this wants us to do is find an equation for the parabola that this light makes, okay? So we know one thing right now is that this light here is at the focus. So if this is our focus, we can make this spot here our vertex. And without knowing anything about our parabola, we know the vertex is going to be either the lowest point or the highest point, or in this case, the furthest left point of our parabola. So that's where our vertex is going to be. We know our focus is here, which is 1.5 inches away from our vertex. So this automatically tells us our p-value here. Okay? So one thing that we need to note or think about is, well, this parabola is opening to the right. So opens right. So that means two things. Our a value is positive, and our y is being squared. So we're going to be looking at our equation of x equals a times y minus k squared plus h. This is the equation that we're going to be using. And if we were to pick a point for our vertex, it's easiest to pick the point 0, 0, just the origin. It doesn't matter what point you pick, but 0, 0 is just the easiest for your vertex. So that is our HK, so we could plug that in, and we also know that our p-value is 1.5. So the other piece of our equation that we're missing is our a value. Since we know our p-value is equal to 1 over 4a, this 1.5 can help us figure out what our a value is so we can plug it into our equation. So if we have 1.5, we set that equal to 1 over 4a. When we cross multiply 1.5 times 4, that's 6a. Don't forget about the a. That equals 1. If we divide both sides by 6, that gives us an a value of 1/6. So if our a value is 1/6 and we know our vertex is 0, 0, we can plug that information into our equation here. So we have x equaling 1/6 times 0, y minus 0 squared plus 0. So we can simplify that to be x equals 1/6 y squared. And this is our equation for this parabola. Okay, so moving on, it says write the equation of a circle. So it tells us right away it's a circle, so we know it's going to be in this form. Our x minus h squared plus y minus k squared equals r squared, and has a center of 5, -2 and a point of 3, 7. So center, that's HK. And if it's just a point, that's just going to be XY. So that means we're missing our R squared. We have to try to solve for our R squared. So what we do is we plug in our H and K and our 3 and 7 into its designated parts and solve for our R squared. So when we do that, we'll get 3 minus 5 squared plus y is 7, k is -2, squared equals r squared. We simplify this, and we have 3 minus 5, that is a -2, squared plus y minus negative 2, 7 minus negative 2, that's 9 squared, equaling r squared. So we'll get 4 plus 81 equals r squared. So when we simplify that, we'll get 85 equals r squared. So your gut response might be to take the square root of both sides and solve for r, but we only want r squared in our equation. So all we do is we take this 85 and we plug it in with our h and k, and that would be our standard form. So we'll have our x minus 5 squared plus y plus 2 squared equaling 85. So that is our standard equation for this circle that it describes. If we're moving right along, our first step for this problem is to say, okay, we have one variable that's squared and one that's not. That automatically makes it a parabola. So your first step when you're just given an equation is to figure out what conic section it is. So we know this is a parabola. The shape, and that is wanting you to list either wide, narrow, or normal. So since our a value is 2, it's greater than 1. That makes this narrow. Our orientation, which way is it opening? So since our y is being squared, that means it's going to open to the left or to the right. But since our a value is positive, we know it's going to open to the right. Now, because our y value is the one that's being squared, that means our 5 is our k and our negative 1 is our h. So our vertex is actually going to be negative 1, negative 5. And since it's opening to the right, our axis of symmetry is going to be a y value that goes through our vertex. So y equals negative 5. And remember, since our y value is being squared, it's not a function, so we can't plug this into our calculator and find our y and x-intercepts easily. We have to solve these by hand. So to find our y-intercept, we set our x equal to 0, and to solve for our x-intercepts, we're going to set our y equal to 0. So to solve for our y-intercept first, we look at our equation, we plug in 0 for x, so we'll get 0 equals 2 times y plus 5 squared minus 1. Add over the 1. And then we need to divide both sides by 2, so we'll have 1/2 times y plus 5 squared, equals y plus 5 squared. So to get the y by itself, we take the square root of both sides. So we'll have this plus or minus the square root of 1/2 equaling y plus 5. Now if I asked for an exact answer, we would have to rationalize this. Okay, so I'll show this in orange to rationalize this. Square root of 1/2, that's the same thing as writing square root of 1 over the square root of 2. So square root of 1, that's 1. We can't simplify the square root of 2, but we need to get this root 2 out of the denominator. So we multiply top and bottom by square root of 2 to get square root of 2 over 2. So that's the same thing as the square root of 1/2, okay? So if we were to just rewrite this, make it rationalized, we'd have plus or minus root 2 over 2 equaling y plus 5. To get y by itself, we would subtract over our 5, so we'll get negative 5 plus or minus root 2 over 2. Now, sometimes I may ask for an exact answer for your y-intercept, so you would have to know this. But when you're plotting your points, this doesn't help you too much. So let's find an estimation of those points. So when we do that, when we plug that into our calculators, we would get a negative, x value is 0. Erase that. So we get 0, comma, negative 4.3. And then we're going to get 0, comma, negative 5.7. Okay, so I just plugged in negative 5 plus root 2 over 2 and negative 5 minus root 2 over 2. To find our x-intercepts, we set our y equal to 0. So looking at our original equation, we were just setting our y equal to 0. So x equals 2 times 0 plus 5, which is 5, squared minus 1. So we'll get x equals 2 times 25 minus 1. So that means our x is going to be 49. So 49 comma 0 is our point. So at this stage, I would graph everything that you know so far. Negative 1, negative 5. And we know our y-intercepts are 0, negative 4.3, and 0, negative 5.7. And our x-intercept of 49 comma 0, that is way off our graph, so we're not going to worry about it. We just know that our parabola is going to be very narrow. And I graphed this first to help me to visualize where my focus is going to be. Okay, so when we're doing these last three steps, we have to remember that our p-value is equal to 1 over 4a. Our a value is 2, so we just take our 2 and plug it right in here for our a. Okay, so I just wanted to let you know that there are two parts of this video, so you can stop this video now and go on to the second part. Okay, so part 2, it's on the Moodle page.